Hi students, I want to show you how the simulation forces and motions work. So for example, you can click here in the force, and then you can start adding forces, just moving these guys to each side of the car, right? So for example, here we see how we have a force to the left. If we pick in that is greater than, the arrow, the vector is greater than the force to the right. If you pick you check at these boxes here, so no forces, values, speed, you can see that the force to the left is the force of 100 newtons, to the right 50 newtons. The sum of the forces is 50 newtons, so you can predict that the system will be moving to the left, because there will be a force pointing to, an unbalanced force to the left. So there will be an acceleration to the left, and we're going to see how the speed is increasing, because there is an acceleration. So there is an increase in the speed of the car. You can now return to the original position. You can add now more of these guys, right? And now we have a force to the right that is higher. If we add one more guy here, we have the same force. We click go. The car is not moving at all. The velocity is zero. Why? Because we have a force that is, the net force is zero. So we have a force of 150 newtons that was balanced with other force of 150 newtons. You can click here also in motion. So in motion, you can just now click, of course, in values, masses, and speed to know the masses of everything. And now just clicking here in this knob, you can move the guy. The guy applied, in this case, a force of 270 newtons, release the box, and the box is moving forever. It's not going to stop ever because there is no friction and have a constant speed, right? Because as there is no force acting, there is no acceleration. We can also click here in friction, so we can add some friction to the system, right? And then we can say to the guy, okay, if I want to just put more mass, right? And then I want to see the sum of the forces, values, masses, speed, everything. So the guy is gonna now be pushing in this sort of direction. You see, the friction is too high. Look at this, there is now an unbalanced force of 154 newtons. There is a friction of 264 to the left. When the guy stops pushing, then you see how the box does stop due to the friction. So well, this is how the simulation works. You can play with the different things, with the different options of this simulation, and following the instructions, answer the questions of the lab practice.